So the distance between alpha u and v should be minimized, right? Of course, the only flexibility that I have is alpha, because given u and v, I mean u and v are given, right? So what is this? How do you find distance between two vectors? Huh? How do you find distance between two vectors? Norm difference, right? So let me look at norm difference, alpha u minus v norm. Minimizing a norm is same as minimizing norm squared also, right? So I can write it like this. Okay, so this is same as minimize over all alpha u minus v whole transpose alpha u minus vy. This is a Euclidean norm. So it's induced by v transpose v square root is the Euclidean norm. If the square of that is v transpose v. Is this fine, everyone? Right? Okay, so this is same as minimizing. So it will be, first term will be what? Alpha squared u transpose u is norm of u squared, right? Minus alpha u transpose v minus v trans, so it's alpha times v transpose u, then finally norm of v squared. This is what you have, right? But the last term is independent of v, so I just have to optimize this with respect to alpha. What kind of a function is this? Let me write that. Alpha squared norm of u squared minus 2 times alpha u transpose vy. U transpose v is same as v transpose u, right? So that's why it's 2 times. I want to minimize this with respect to alpha. So if you plot this alpha, how does it look like? Yeah, it's a parabola, right? So it's a quadratic, right? It means it's like this. This is called convex functions. We will see what a convex function is. But this is something that I can assume because you would have studied this in other courses. So how do you find the minima? Differentiate and equate it to 0. So you differentiate and equate it to 0. What do you get? 2 alpha norm of u minus 2 u transpose v equal to 0. So this implies alpha is u transpose v divided by norm of u, right? So that means, what is this vector? So I want this alpha u, right? Alpha turned out to be that. Alpha u is what? Alpha u is u transpose v u divided by norm of u, right? That's what we got. In fact, by our intuition, we got the same thing, right? Here also. We look at 2 dimension. See, this is this. U1 is V1 over norm of V1. We got this exactly same. Do you agree? Now, this will give us a way, right? So, how do you find U1 and U2? I mean, how do you do this for 2 dimension? What do you think is the solution? Yes. What do you think is the? So it's definitely this should be orthogonal, right? For V2. So what should be alpha 1, alpha 2? See, here alpha turned out to be what? Alpha turned out to be a function of V, right? So this is alpha. It's a function of V, the other vector, right? So similarly, what do you think will be this thing? So suppose I have, let's say, V1, V2, and V3. There are 3 vectors. I have converted this into U1, U2, and this is what I'm looking for, right? U1, U2 are orthonormal. I know how to do that. But U3 is the issue, right? So what do you think this should be? So first thing is, I'll construct a vector, let's say V, which is alpha U1 plus beta U2. Okay. This corresponds to this point, right? But that point should be orthogonal to what? So this is the point, but if I subtract V2, right? So this is nothing but this point, this vector minus this vector is V3, right? So that should be orthogonal to what? Itself. Do you agree? Is that fine, everyone? Okay, so this should be, now we have this vector. So what we should be, so if you look at V minus V2 should be orthogonal to V, right? That's what we want. You agree with this? Right? V minus V2 is the orthogonal vector. That should be orthogonal to V itself, right? That's what we get, right? So what does this translate to? V minus V2 transpose V is 0, right? So what is V? V is alpha U1 plus beta U2, right? This is V minus V2 transpose, again, alpha U1 plus beta U2 is 0. I want to have this, right? So is that fine, everyone? It's okay? This should be orthogonal to, the difference is orthogonal to this, right? So if I choose alpha and beta such that this happens, then I'm done. I have found the vector V, right? So which is orthogonal. Then everything, you can move forward. Now, I will leave this as a homework problem. So you're supposed to find this alpha beta. How do you find this alpha beta? Okay, so there are other ways of figuring this out. So for example, this is the vector, and let's say this is three-dimensional vector. This is alpha V1 plus beta V2, and this is, or let's say U1 U2, right? That's what we had, U1 U2. This is what? This is some V3. I want to minimize this distance. So that means, alternatively, what do we have? I want to minimize the distance between alpha U1 plus beta U2 and V2, right? Or alpha beta. It leads to an optimization problem, right? Do you agree? So already we have an optimization problem here. Okay. So now, essentially, if you solve this, you will get alpha beta, right? Now, if you plug in that alpha beta and get alpha U1 plus beta U2, that's the projection vector of V2 onto the span of V3 onto span of V1 V2, right? That's, or U1 U2 for that matter, right? And you normalize that, you will get, I mean, you get the difference, and then normalize the difference, you get V3. Keep on doing that. So what is projection now? Projection attempts to do this, okay? This is projection. Projection of, okay, so I think I should teach you one more thing.